go through the problems, set questions, and it's best if you ask questions about the particular question, and then we'll discuss all of them, if that's okay. I will put the announcement just so that people who are joining know. Email Toby, that's obviously the best way to do that. Hey, I'll stop now. I've made an announcement again, just covering what we've done. One general piece of advice that I have for you, obviously, it's not a typical year. I hope you all stay safe. That's the priority, and we'll try our best to cover, to keep you safe. That's the priority this year. In terms of the seminars, what I do suggest, I recommend you to do is try to prepare yourself before the seminars, try to answer the questions. It's understandable you won't answer all of them, but it will pay off in your future revision. The more you practice, the better you will become in understanding the materials. It's also good that you follow the material both from lectures and problem sets consistently, because next classes will gradually expand what you are learning in each seminar. It's important for you, in my view, for you to try to stay on top of what we are covering. I'm sharing the screen, so you hopefully should be all able to see it. We have 5 questions to cover. In the first question, we'll look at the indifference map. One thing, the material that we'll use today, it won't be posted. Instead, you will have the solutions. So after each class, you will have solutions to the problems that posted online. Let's start with question 1. So in this question, we have the indifference map as defined below in the diagram. And we are supposed to compare the 2 points, point A and B, and define which is the preference for that particular individual. We have pizzas and we have cola. So that's 2 goods. Remember, we have one important assumptions when we look at those indifference curve. And the main assumptions on those indifference curve is the monotonicity. Monotonicity states that if we both prefer both goods in higher quantities, then you should be better off. In this example is if an individual prefers more of pizza and more of Coke, that's the case where that individual should be better off. Okay, that's the question, and let's show it by means of a diagram. So we have those 2 points, point A and point B. In this point, individual has more pizza, right? That's because we compare those 2 points. So this is point B for pizza, this is point A for pizza, which is point A is just higher than point B, right? So the individual at point A has more of pizza. Now, it's just the first good, so the question is, does individual A also have more of Coke? So we look at the y-axis. This is Coke for A. This is Coke for B, which is actually higher. So it's not the case that the individual has more of both goods. That's the reason why we cannot directly apply monotonicity, right? Because it's not the case that the individual has more of both. However, what we can note is that point B is at the higher indifference curve, right? That's how we can compare those points. This is indifference 2, and this is indifference 3, which is at the higher indifference curve. If that's the case, then individual at point B will just have higher utility compared to individual at point A. One notation that we will introduce is notation here. So remember, it's very much related. This is utility at point B, which is higher than utility at point A. And that's just in terms of the value. But we can also write down, and we will use that expression here, that B is simply preferred to A. And this is the same way of stating that. Now, let me look at the chat with the questions. So answering admin questions, so the seminar won't be recorded, but you will have answers to the seminars once the seminars all throughout the week are finished. Now, a good question from Hongshuan Zhang. Is it good to create point C right below B to help comparing? Yes, it's a good way to do that. And why would you do that? Do you want to answer via chat, or if you want to answer the questions, you can always unmute yourself, right? So would you like to unmute yourself, Hongshuan Zhang, and say why would you pick a point C?
Yeah. The questions said that, can anybody hear me?
I think I can hear you, and I think everyone else can as well. It's hard to have everyone answering, so yes.
Well, please. I think this is because the question itself says that we should use the exams of transitivity and the monotonicity, so that I think create the C can be useful to adapt the transitivity and monotonicity, so that I will create the C right below the B point and use transitivity to compare B and C and A, and then have a conclusion, so that I can adopt both of the transitivity and monotonicity.
Yes, and how exactly would you do that? It's a very good example. So you suggest to put point C below point B, right?
Oh, sorry. I mean, create the C in the same indifference curve as A.
Yes.
Right below the B. Mm-hmm. Right, the A.
That's
and then
this point here, right?
You can compare C to B, because B has the same pizza and more Coke, so that B is preferred to C. And as A and C is indifferent, then B is preferred to A.
That's correct. Perfect answer. Thank you very much. Right, so let me just say that again, what you mentioned, but it's a very good description. So what we want to make that trick is to put point C just below point B. Why? Because then we can apply monotonicity. If I have more of Coke and the same amount of pizza, I will be better off point B as opposed to point C. But C and A are on the same indifference curve. So C must be as good as A. If that's the case, then we can apply transitivity. If B is preferred to C and C is equally good to A, then B will be preferred to A. Luke asks also a good question. You can certainly create point C above point A. Right, so the idea is directly above point A, then it means that you can apply monotonicity. C will be preferred to A because we have more Coke and the same number of pizza, and then C is as good as B. So therefore we can say if B is as good as C and C is better than A, then B will be better than A. Analogously, what we can do as well, we can choose a point C that is not above, directly below point B, but it can just be directly horizontal to the left of B, right? So point C here, as long as it's on the same indifference curve as A, is still going to enable us to use the same argument. So if we have point C here, B has the same amount of Coke, but it has more pizza. Again, B is preferred to C by monotonicity. C is as good as A. So by means of transitivity, we can say that B preferred to C, and C is as good as A, and therefore B will be preferred to A. Very good. Are there any questions about question 1 there? Okay, let's move to question 2. Is it possible for a consumer to have the indifference map shown below? We have, again, the same goods, cola and pizza. We have point A and D, which is on one indifference curve. And we have B and C on the other indifference curves. So let's think about whether why cannot those points cross. Does anyone want to find suggests a procedure for that in the chat?
Is everything okay?
Okay, so let me just answer final questions on question 1. So as long as you are not asked in the marks, then showing that by 1 means is enough, right? As long as you find point C. And review exactly what you say. So we can either use monotonicity or transitivity, or we can refer to indifference curves. William, would you like to unmute yourself and show your argument?
Yeah, so I was just saying that we can see B is better than A if we're assuming monotonicity, but also D is better than C. So A and C are the 2 worst points. So A and C should be on the same line, and B and D should be on the same line.
Okay. Almost correct, but how can you say exactly that A and C are 2 worst points?
It violates the anti-mode transitivity.
Yes, that's correct. And how? Can you just explain?
It's because A and C are the worst points and B and D are the same. It's just the law of the transitivity that they can't intersect. 2 indifference curves cannot intersect. Simply, that's the law. So yeah.
Yeah. So as you say, A is worse than B, C is worse than D, but then you have to also explicitly link it, but C is on the same indifference curve as B. And that's where you can apply the argument of transitivity to say that your original statement that B is preferred to A can no longer hold. Let me show that again, but exactly what you said is correct.
What are your plans for today? What are you doing? How are you feeling?
Sorry?
Not gonna do anything.
Okay, so first what we can do is collect all the information. B has more of everything relative to A, so that's by monotonicity. And D is preferred to C, also for the argument of monotonicity.
Well, there's nothing to do, honestly, and I have a lot of work to catch up on as well. I want to go out.
I would like to ask you, you have to mute yourself because otherwise people can hear you. So please only unmute yourself when you when you talk about the questions, please. Otherwise, exactly, yes. So now third argument is that B is equally good as C because they are on the same indifference curve, and then A is equally good as D because they are on the same indifference curve as well. So now collecting that information, we haven't applied transitivity yet, but we have all of our information that we can apply it, and the idea is to arrive at the contradiction. So we need to collect information at 3 points at the same time. B is preferred to A, but B being on the same indifference curve to C, then by transitivity, C must be preferred to A. This is exactly what we did in question 1. But we have here 2 indifference curves, so let's apply the same arguments to the other 2 points. So again, this is monotonicity, but A is on the same indifference curve as D. So A should be preferred to C, but those 2 arguments cannot hold. And then we arrive at the contradiction. We arrive at contradiction because of the fact that those indifference curves have crossed. Let me repeat that argument again. This just comes from our graph. And let's just focus on the first argument here. So we apply all this information that we have, and based on that, we can use the transitivity to find out something more. B is preferred to A, that's the monotonicity here, clearly seen from that. And then we just state that B is on the same indifference curve as C. Why we want that? Because remember, to apply transitivity, we need actually 3 points. So here we have information on the 3 points, and then transitivity can enable us to compare B and C. C and A. Right? This could not happen initially because we can't apply monotonicity C over A, but by transitivity we can conclude what must be happening. Then the rest is the same argument, but comparing different points. So again, this is the second case where we can apply monotonicity, D and C. We want to compare it with another point, so we choose that indifference curve. And it would lead us to state that A is preferred to C. But now the 2 things cannot hold because they contradict each other. And the reason is that those indifference curves have crossed. So learning the notation, there isn't anything else to learn other than just using this to, this will be the only notation that you use, right? So it has some intuition because B preferred to A is the same as utility of B being higher than A. And obviously you can do it also by means of writing, of just doing it descriptively. In my view, it's just more convenient to do it this way, but obviously you can do it either way, right? So that equation is in terms of utility being higher or in terms of points being preferred to each other, right? Similarly, if the utility is the same, so that would be equality sign, and that would be the tilted version of that description. That's why I was using either this or that. You can obviously explain that by means of words as well. And now the question for you to think about it. Imagine you can pick 3 points, just for any 3 points. So take a moment to think about the question. So it's not the points that you pick, but any points that you can pick to show the same arguments. How could we do that? Let me say to everyone. Let's take a moment to think about if you can pick any 3 points to show that indifference curves cannot cross. Brilliant. Yes, Reviro, that's exactly that argument. How would you explain that then? Why would you pick all those 3 points?
Was I supposed to explain this?
Yeah, if you don't mind.
Oh, yeah. So if you take the first curve, let's say I1 as the point with B on it, and I will name the intersection point, let's say E for now. So therefore, points B and E would be indifferent, which means they have the same utility. And then if we take the second point A and the second curve I2, points A and E would also have the same utility and they would be indifferent. But if we take points A and B independently, B clearly has more of both the goods. So by the law of transitivity, I think, B has to be chosen over A. But in the case that these two intersect, all 3 points would have the same utility, which is not possible in theory.
That's correct. Yeah. Thank you. Let's see that again. How you argued in this case. So using 3 points, we have point A and B as before, but the trick is to place the point X at this intersection. And then the rest is analogous. So we know that B is preferred to A by monotonicity, but B is on the same indifference curve as X, which would then mean that X should be preferred over A. However, we note that A and X are on the same indifference curve, so there should actually be equally there should be indifference between the two, and those two again cannot hold, so that's again a contradiction. Let's move to question 3. Sally has preferences for fruits. She doesn't care. That's the key argument. If she eats apples and oranges, but only cares about the total number. Right, so this is the case of perfect substitutes. How we could draw the indifference curve. And there is the hint, right? To first draw one indifference curve showing the combination of the fruits where she has exactly 5 apples and no oranges. So how can we do that? So we basically start with the point where we have just 5 oranges and no apples, right? That's this point here. It's 5, 0. Crucially, she does not care whether she has oranges or apples. So all the points where she has 5 fruits in total would give her the same utility. So this is another point that will be on the same indifference curve, point 0 and 5. But also any points which give 5 fruits in total would give her the same utility. So 2 oranges and 3 apples will also give her the same utility. Now, connecting all this information, we can then show an indifference curve where she has the same amount of utility, right? Those are all the points where she has 5 fruits in total. And the final component is to show different indifference curves. So one example would be to show it for 4 fruits in total, and that's where her utility will be lower. Right? So those are these parallel indifference curves, right? This is where she has 5 fruits in total. Having 4 fruits in total will give her always the same utility, but it will always be lower than 5. That's the example of perfect substitutes. It does not matter which axis has apples and which has oranges, right? In terms of the axis, in this case, it will be the identical cross. Are there any questions about question 3? First graph again. We basically want to show all the points where she has the same number of fruits. So if she only has oranges, that's 5 oranges and no apples. And the second point is the point where she still has the 5 fruits in total. So that point could be just having apples. So it's 5 apples and 0 oranges. Now having 2 and 3, 2 oranges and 2 oranges and 3 apples. 2 plus 3 is 5, so it's still 5 fruits in total. And therefore, any of those points giving 5 fruits in total will make Sally indifferent. Okay, does that answer the questions? Are there any other questions here? good question. So the gradient will be constant. M marginal rate of substitution in this case is constant, but it does have to be 1. First of all, it all depends on the actual shape of those curves, right? So this is where there are perfect substitutes. That will be that the gradient is constant, but its value will depend. For instance, if you prefer 2 oranges to 1 apple, it will still have the same. The gradient will be constant, right? In terms of substitution effect, yes. So the substitution effect will be constant again. It's because of the marginal rate of substitution. Drawing many lines or just one line, it depends on the question. So the hint is that we draw here. The hint is draw one indifference curve. But if you're asked to draw indifference map, you need to draw many lines. Let's move to question 4. Caroline has normally shaped feet, so she always wears 1 left and 1 right shoe. That we will see is an example of perfect complements. Draw an indifference curve showing her preferences for left shoes and right shoes. Again, a hint is not about preferences, it's just about one single indifference curve. And here it's to show that Caroline's equally 2 left shoes and 2 right shoes. Let's see how we would draw that point. So we have right shoes and left shoes, and first mapping 1 point is this point here, where we have 2 of right and 2 of left. Now, adding 1 more right shoe without adding any left shoe, it means that she cannot use the extra shoe. She always needs a pair to make use of it. Analogous, if she has 5 right shoes, but still 2 shoes, that's where she will be indifferent. And that argument applies to increasing another shoe while keep one of those shoes amount constant. Therefore, if we start again with 2 pairs of shoes, 2 right and 2 left shoes, keeping 2 right shoes but increasing left shoes will not make that individual happier. You cannot use more of 1 shoe only. And we can collect that information to find the first indifference curve, which is this I2. So that's the curve where we have 2 of left and 2 of right. Now increasing just right shoe, that's all those points here, will keep that individual with the same utility. And so is the case where we have just left shoe increase, right? Now it changes if we increase both of right shoe and left shoe. So if we have 3 of left and 3 of right, then we are on the higher indifference curves. And again, starting with 3 left, no matter how many right shoes we add, we're still going to be on the same indifference curve. And in the case of perfect complements, that's the special case where we have those L-shaped indifference curves. And that's perfect compliments. Any questions here on question 4? Okay, let's finish with question 5. So in question 5, we introduce the budget constraint. So show their optimum consumption point by combining the indifference curves with the budget constraint. So remember, what is the shape of the budget constraint? Is always going to be with the same slope, right? So indifference curves might have different slope, but the budget constraint will always have the same slope. Let's see it with an example. So here we have the preferences for apples and oranges. So these are perfect substitute as we identified, and we have the income constraint, so budget constraint, which will always be straight line, right? That's the red line here. And because of the slope of those red line is how much up we can go in terms of satisfying our preferences that is achievable by means of the income. So one potential example is just to buy apples. That means that we have 2 fruits in total, and that's achievable because it is within our budget constraint. But we can do better because we can actually have 3 of oranges and no apples. That's still achievable because it is the farthest point on this budget constraint. And implicitly what's happening is that oranges are cheaper. For the same budget, we can buy more oranges than we can apples because oranges are cheaper. And if oranges are cheaper, we will be better off just by buying oranges. Remember, in perfect substitutes, we don't care whether we have oranges or apples. We only care about the total number of fruits, right? So 0.30 will be preferred over 0.02. Random budget constraint, that's a good question. So we will draw the budget constraints in the next class, but for now we just assume that it's given. And obviously it's not actually given, it's determined by the prices. So you have certain income, let's say £10, and then depending on the prices of oranges and prices of apple, you will get that red line here. And to follow up on that question, we can exactly have different prices, and those different prices would be corresponding again to a new budget constraint, such as this blue line here. Again, it will always have the same slope, but in this case, it is apples that are cheaper, right? Why is it the case? Because looking at the individual, now 3 apples and no oranges is affordable, but 3 oranges and no apples is no longer affordable, right? So comparing those 2 budget lines, this was one slope where oranges were cheaper. This is another slope when apples are cheaper. And depending on those prices, if apples are cheaper, then we will actually only consume apples. The final point is what happens if our budget increases. So budget increasing will basically shift this curve outward, right? That's where instead of £10, we have £20. But in terms of the outcome, we would still only consume apples in this case. Why? Because we only care about the total number of fruits. if apples are cheaper than oranges, we would always consume apples anyway. So just to explain that again, for now, think of this as budget. So we don't need, I mean, it's more of a conceptual exercise here. In future, you will be given prices, so you will draw your own budget constraint. So if you believe that budget constraint, you could actually, to some extent, identify the prices. You could do the reverse exercise. But for now, just assume that you are given this budget constraint and you would be asked what is the optimal consumption choice. If you are giving this budget constraint, this is the optimal consumption choice, but in the next classes you will actually be told to draw the budget constraint. So you will identify it yourself, and then it will be more intuitive to look at those optimal consumption points. Okay, any other question about today's class? Excellent. Thank you for listening. And as I mentioned, so you don't need to attend any other seminars this week if you attended this one, but there are also face-to-face seminars scheduled. Okay, I will answer those questions. If you need to leave the meeting, that's okay, but I will answer the questions that were still placed on the chat. So, so substitution income effect, we will look at this more closer next week. So please hold on to that question until we go into detail, because we don't